Why choose a parallel flow heat exchanger design? Imagine trying to warm up a cold room with a heater. The way you set up the heater can change how fast and evenly the room warms. That's similar to how heat exchangers work in energy systems. Today, we're talking about why a parallel flow heat exchanger might be the right choice for certain jobs. In this design, both the hot and cold fluids flow in the same direction, side by side. This setup makes the system simple to build and operate. Because the flow paths are straightforward, the piping and controls are less complicated. This means easier installation and lower costs. Plus, cleaning and maintaining the system is simpler, saving time and money over the long run. One big advantage of parallel flow is the high temperature difference at the start. When the fluids enter the heat exchanger, the hot fluid is much hotter than the cold one. This large temperature gap causes heat to transfer quickly at the beginning. If you need a rapid change in temperature, like quickly cooling a hot liquid or heating something fast, this design is very effective. Another reason to choose this setup is when the goal is to get both fluids close to the same temperature at the end. For example, in some chemical processes, you want to cool a hot fluid down to nearly the temperature of the cooling water. Parallel flow makes this easier because both fluids move together and gradually approach each other's temperatures. This design also helps keep the wall temperatures more uniform along the heat exchange surface. When the temperature stays steady across the surface, it reduces the risk of thermal stress. That means the equipment lasts longer and is less likely to crack or break over time. Safety is another benefit. In applications involving water or other fluids that could freeze, parallel flow helps keep temperatures above freezing points. This reduces the risk of blockages or damage caused by freezing. However, it's important to remember that parallel flow isn't perfect for every situation. Because the temperature difference between the fluids decreases along the length of the heat exchanger, the overall heat transfer efficiency is lower than in other designs. If you need a large temperature change for both fluids, a different setup might be better. In practical use, you'll find parallel flow heat exchangers in heating, ventilation, and air conditioning systems, as well as in some industrial processes. They are chosen when moderate temperature changes are enough, and when simplicity and cost savings are priorities. They can also be combined with other technologies, like phase change materials, to improve their performance in managing temperature fluctuations. So, if you want a system that is simple, cost-effective, and capable of quickly bringing to fluids to similar temperatures without stressing the equipment, a parallel flow heat exchanger could be the right choice for your needs.